I want to talk about the Pauli exclusion principle. If we were to state the Pauli exclusion principle succinctly, we might say that no two electrons can have all four quantum numbers the same. And this kind of makes sense when you think about it, because if quantum numbers specify sort of the position of an electron, we know that it doesn't really specify the position because we can't know the exact location and momentum of an electron at any particular time, but it gives us an idea of the location of the electron. To say that two electrons have all four quantum numbers the same is almost like saying they're occupying the same place at the same time, and that's not going to happen. Well, what does the Pauli exclusion principle mean for us? Well, it means that there's a limit to the number of electrons we can put in each of the subshells. So, for instance, if we try to answer the question, how many electrons in an atom can have n equals to 3 and L equals to 1, we know that n is the third shell and L equals 1 generally corresponds to the p orbital. We also know that when L equals 1, m sub L has to be 1, 0, or minus 1, so there's three possibilities there. Each of those m sub L values can have an m sub S value, or plus or 1/2 or minus 1/2. So for our three m sub L values, there are two different possibilities each, or 3 times 2 possibilities gives us a total of 6 electrons. Another way to think about this is, as I said, that the L equals 1 corresponds to a p orbital, and that means that the 3p orbital can hold a total of 6 electrons.